Billing it. However long it takes, man, I'll still be here, you know what I'm saying? Yo, new year, new money, but it's the same old me. Need the yard that don't come cheap before I get 8 gold teeth. They wanna play with sticks and stones, I'm calling them Jamie T. Up chasing coins like Sonic, could trust me, they don't sleep. Play my songs out of whip, she said keep that shit on repeat. Billing it, however long it takes, man, I'll still be here, you know what I'm saying? Yo, new year, new money, but it's the same old me. Need the yard that don't come cheap before I get 8 gold teeth. They wanna play with sticks and stones, I'm calling them Jamie T. Up chasing coins like Sonic, could trust me, they don't sleep. Play my songs out of whip, she said keep that shit on repeat. Billing it, however long it takes, man, I'll still be here, you know what I'm saying? Yo, new year, new money, but it's the same old me. Need the yard that don't come cheap before I get 8 gold teeth. They wanna play with sticks and stones.
Should I get started? All right. Welcome to Startup Village Hanoi. Today we are here with MagicBlock. My name is Jonas. How are you guys? Thanks for the energy. There's some echo here. How should we do that? Or maybe just turn it off. Yeah. All right. There's something more here. It's good. Then I turn it on here. And there's something there also. Awesome. Okay, now we have fixed the technical issues. Who of you are building a project on Solana? Hands up. Who have already deployed on DevNet? Hands up. Or just 3 of you guys? All right, no problem. Mainnet. Oh, of course, mainnet. Yeah, glad to see some of you builders here. My name is Jonas. I'm from MagicBlock Developer Relations. And MagicBlock's vision is to give you and your Solana programs superpower. Like Red Bull gives you superpower to have wings. We give you superpower in terms of performance, privacy, cost benefits, and much more. The only difference is Red Bull doesn't actually give you wings, but we give you superpower. So yeah, we do it by using ephemeral rollups, something that we have innovated on, and I would explain more about how it works, why we use it, and also how you as a developer and builder can integrate with ephemeral rollups, and how we can support you to bring your project from a hackathon project to a successful business. All right, let's dive right into it. So the key points that I'm gonna talk about are acronyms like ER, TE, and VRF. Maybe some people don't know what it is. We will clarify on that. And at last, we're gonna talk about the opportunities and how we support you to bring your project to business. First, ER. ER stands for ephemeral rollup, or ephemeral rollup ER stands for ephemeral rollup. And the problem that we're solving here is a key problem in terms of blockchain applications. If you look at this application, it's called Supersize. On the left hand, you see if you would deploy it, the game experience when you have deployed it on Solana. And the right hand side, you can see when you deploy it on MagicBlock. What's the difference? Hands up. Speed. Yeah, it's the user experience. It's laggy, right? Not only laggy, but if you want to scale this application to millions of people around there, you have to incur a lot of costs in terms of transaction costs. And it may not be scalable having the throughput that you need for your application. So that's why MagicBlock exists, to help. We initially come from game development, supporting developers to build games with our Bolt framework. And then we realized, oh, we have the game, but then the experience was not great. So then we moved on or pivoted with ephemeral rollups, and we have identified not only helps with games, but also other applications. One of the existing games that are using us is Block Stranding. Maybe have you heard about Block Stranding before? Yes, they are quite hyped recently. So you can see here every movement on this map for this player while it's killing some kind of artifacts. It's a transaction, and it happens very fast, faster than 400 milliseconds. If you haven't played it, you can try it out at blockstranding.com. And this is a totally new category of games that we can enable on the blockchain. Also, another application that have been using us is Zbit. Do you know Zbit? Hands up, Zbit? Okay. Zbit is a platform for you to play financialized games. So you can deposit some money, and then you can start using different games, like this tower game, to basically bet, oh, will here be the diamond or will there be a bomb? And you can then 2x, 4x, 3x your bet, basically. And that happens, again, also in real time, because every time you select the zone here, if you want really good user experience and you want it in a scalable way, that's where Zbit is using us, MagicBlock, in order to empower users with these kind of experiences. Not only games, but also DeFi is very, very a critical application on MagicBlock. So on the left-hand side, you can see here a price feed, which is right now Solana. And we are using PIF laser to basically store the price feed, price feed in terms of one update per 1 millisecond. And on a thermal rollup, you can see here how many updates per second we can enable, which is around 20 updates per second, which is a latency of 50 milliseconds, basically. And with such fast price feeds, we can allow applications like Flash Trade to do better for the users. They can provide lower risk because they can liquidate faster and more precisely when price changes happen. And they can allow market makers to bid without any fees and allow them to withdraw their bids if they want to change their bids, and a lot more. In summary, we know that time is money, and if we can save time for the developers, for the users, we can save them money and increase their profits. So MagicBlock, in summary, is an infrastructure for you as a developer to utilize the best of two worlds. In Web 2, you have the benefits of performance, cost, and scalability. In Web 3, you have the benefits of composability, verifiability, and ownership. And with MagicBlock, we can bring the best of those two worlds together and give it to developers, the users, market makers, liquidity providers, and so on. Compared to other, let's say, rollups, as we know, let's say Ethereum has also rollups, the benefit is that the Solana program that you built on Solana doesn't need to leave Solana. For example, if you build on Ethereum, you need to deploy a program on Ethereum, but then if you go to Arbitrum, you need to deploy your program also on Arbitrum, right? And then Arbitrum and Ethereum cannot talk to each other. If you want to make transactions on Arbitrum based on states in Ethereum, you can't do it. But with MagicBlock, your application stays on Solana, and on the firmware rollup, you can execute transactions in real time, 0 fees, while having access to data on Solana. So you can be fully composable with Solana, while being highly performant, low cost, and scalable. So what we have enabled for many projects here, you can see here, we have enabled 100x lower cost for depend projects and games such as Supersize. We have enabled 40 times faster transaction speed in DeFi games such as Flash Trade. And something new also, what is coming up, which I will talk more about, is private transactions. We can allow you to build applications that can utilize privacy on Solana. Yes. Yes, yeah, we will go into that. Yeah. Thanks. So let me share with you how it works. So on Solana, imagine yourself, you're on the road with the car, with the transaction, right? 400 milliseconds is your speed limit, basically. It's the block time. MagicBlock, no problem. Important calls, don't worry. Hope it's not too crucial. Okay. On MagicBlock, we have this highway that we built for you, where you can go up on the highway, you can drive much faster, like 10 milliseconds block time. And in the end of the highway, you can always come back to Solana and drive on Solana. So this is how you can imagine what MagicBlock is. And abstractly, you can see here, every 400 milliseconds, Solana produces a block. We can produce blocks every 10 milliseconds. Okay, that means after 40 blocks, we can actually synchronize the state from a roller to Solana. So at the next block on Solana, it has the latest state while being super fast on the ephemeral roller. And how you can enable that performance or superpower for your Solana program is through delegation. So how it works is you write your existing program, right? And you basically delegate your program or your state account, like your PDA of your program, to MagicBlock's delegation program. That means the account, the PDA, is locked for writes. Okay, and with that, we can enable that account on the ephemeral rollup. So when you submit transactions now on the ephemeral rollup, it can execute as it would be executing on Solana, but with real-time speed. And you can make state changes on the ephemeral rollup. And when you undelegate, which is the third step, or commit, which means to sync the state back to Solana, you can do that by locking it on the ephemeral rollup and unlocking it on the Solana blockchain and reverse the owner of the state account to the original program. So this is abstractly how it works. So user submits a transaction. What we also have innovated on is the Magic router. Basically, you can utilize existing RPCs that support Magic routing. When transactions are sent, it can quickly identify whether the transaction is supposed to be executed on Solana or on the ephemeral rollup based on the account metadata. So on Solana, the benefit is we have like account meta, we have the metadata for instruction where we see all the writes and all the reads of accounts. And based on that, we can evaluate where basically the transaction is routed. And if it's routed on the ER, it will be executed in real time. If it's routed on Solana, it will be as usual. So we have our SDK that you can use. And there's just a few lines that you need to do in order to integrate to the ephemeral rollup. We have it available for Rust native, but also for Anchor. This is just an overview. Let me give you an example on how you would integrate with MagicBlock to give your Solana program the superpower. So imagine you build like a counter program. So this is a code of our counter program. You have two functions, initialize, let's say a PDA that stores the count value. And then you have another function which increments the state by 1 when you hit that instruction. That's a normal counter program, right? It could be anything. It could be your game. It could be your vault. It can be anything. But for simplicity, it's a counter program. So that's the first step. You need to write a program on Solana. There's 3 more steps to go. So the second step is you need to install and import the SDK. So we have, as I said, developed the SDK for you to easily integrate it with ephemeral rollups. And it comes with a few macros, also with Anchor, and a few functions that allow you to call CPI calls to our delegation program to lock the account. The third step is you basically add the delegation and undelegation instructions to your program. So how you do it, you can see here in Anchor, on top of the program, you can see the macro ephemeral. What that does is it will allow your program to be, or like the state account that you want delegate to undelegate. So it actually like ingest the instruction for you to undelegate on Solana. So on Solana base layer. And then we have here utilizing a few, here you can see a few functions, which is delegate PDA. This is a CPI call to delegate. And then we have another instruction where you can commit and undelegate. This is basically a CPI call on the ephemeral rollup for you to bring the state to Solana and undelegate and change the owner back to the original program. What you need to do in order, you can see here this function comes from the context accounts, right? And how you can bring it to the context or to that account is when you define a context, you can see here, basically you can put on delegate, and then it will basically have the CPI function available. Yeah, so that's how you integrate with ephemeral rollups. Any questions so far?
So technically, the delegation means you are delegating the account state, including the assets and the current state of the account to MagicBlock. So kind of like wrapping your current state and assets on Solana in one transaction first before you do anything on the ER. Right? Yes, and then you do thousands of transactions on the ER. And do you decide, like, does the state update every 400 milliseconds goes to mainnet, or do you decide, okay, every 10 minutes update the state?
So when you come here, when you delegate, you can specify the commit frequency. So there's an auto commit frequency that you can say every 10 seconds or whatever, every 1 second, it will auto commit. Or what you can do is you can manually trigger that commit. So it's up to you how you want to define it. But you're right. So we locked your PDAs through your program because you basically add superpowers to your program to basically put it on the ER for real-time speed. You lock that by changing the owner to the delegation program, and with that, it's available on the ER. And when you commit and undelegate, you lock it on the ER, and on the Solana base layer, it will be basically unlocked and reversed.
So every delegate and an undelegate has one specific ER. The next time I spin up a new session, it serves different ER, or I can create multiple ERs.
You can have multiple sessions on a ER. So basically, when you delegate, you create a session, and then you delegate it to an ER of your choice. So you can choose one, whatever. And then once you delegate, you undelegate, it's one session, but you can still delegate it to the same ER once again. And yeah, and then you can switch back and forth how many times you want.
Can you have multiple as well for the same account?
Multiple sessions for the same account on the same ER.
Multiple ERs?
You could, but then the composability is an issue because the different ERs wouldn't be as composable. Yeah.
Is there like a central router or something which comes to me?
There's a magic router that you can use where you just use the one infrastructure, and it will basically helps you to route to different ERs as where the account is delegated. Usually you wouldn't have different ERs where you delegate your account. It wouldn't make sense. Rather, you have one account delegated to one ER where everything happens with all the other delegated accounts. And then it is composable with, let's say, mainnet. And then you delegate it back and forth, basically. Or you can just also commit the state. So you can leave it on the ER, delegate it, and just commit the state. So then programs on Solana mainnet can actually read the updated state and be composable with that state.
So let's say it's a game, and there are 100 users playing it right now. Is the main program of that game delegated, or is it like every individual user's account is delegated and every user has themselves an ER?
Yeah, so it's not the program is not delegated, it's the state account which is delegated, so the PDA of the program. You're welcome. All right, any more further questions? Great questions, by the way, thanks. Yeah, let's talk about TEE, which stands for Trusted Execution Environment, where we enable real-time privacy. So this is something we have been waiting for very long, and we see it as one of the largest upgrades to privacy on Solana, which we announced like last month. And what it enables you to do is to build confidential transfers, applications, sealed auctions, private games, compliance flows, a lot of new things, a fully new category of applications that was not possible in Solana. We want to give superpowers to you and to your programs. So that's why we built that TEE for you. And if you compare different privacy solutions out there with ZK, with homomorphic encryption, multi-party computation, they all come with pros and cons. While others rely on computation, we relied on the security of the hardware, which On the benefit side, allows you to compute privacy as fast as possible natively. Let me tell you how it works. Oh, before that, let me show you an application where we have already, which we have already developed, so you can already test it out, how it works with private transfer. So here, let me go back again. So we have this page, private payments. You can create a token, a dummy token, file it on supply. Now you have like an interface for you to send. So here you can see the mainnet balance, and this is the private balance. I'm sending it to an address, 100 of those dummy tokens. You can see it's subtracted. Now it's 900. This is the recipient. I can't see the balance of that recipient because it's private. But when I log in with that account, I can see the 100 balance. I can send it back to my other account, let's say 20 of these dummy tokens. Then I would see here 80. And on the other side, I should see 900. Yes, still, but I can't see the private balance. But if I log to my previous account, I can see the 20 dummy tokens, and I can withdraw that to mainnet, or like to the base layer, and it will be 920 again. So I send out 100, and we did a lot of things, assuming, and then I take out 20, but you wouldn't be able to tell what happened in between. It's kind of like a mixer on the T.
That works only on the assets created on the, not on mainnet.
No, it also creates so what we enable is for token accounts, any token that you want to bridge over, you can do that.
So let's say I want to send you 10,000 USDC privately.
You can do this with USDC.
But then it has to be committed to mainnet at some point, and then it is not private.
Yes, but everything in between, in the TE, you can. So basically, what happens in the back end, you can basically create accounts, private accounts for other users that you're sending to, and they can withdraw that from their private balance, and nobody would know who's sending to them because it's behind the TE. But when they withdraw, they basically take that asset back to the Solana, and then you see how much the person has withdrawn, but everything in between you don't see.
We'll catch you after this.
Yeah, sure. All right, let me tell you how it works. So how we enable that is through a chip Intel TDX that basically allows us to execute in that environment, the trusted execution environment. And what we put on the chip is, one is we have the Solana SVM, okay, plus the synchronization layer, the lock and unlock, which is our ER, right? And plus another layer, which is the authentication layer, which then makes it our TE, ER, where we basically manage the authentication of users who can access which write and read for which account. So how it works is, so this is the TE, this is another instance, right? ER, but on a specialized hardware, the Intel TDX, which is certified for TE, and you can attest and get a certificate to prove that, oh, this is actually a genuine TE, and this code really runs on that TE, similar to what you have on Ledger. It's also having a trusted execution environment where it stores your private key and also the signing for every transaction. But on top of that, how we make it possible with this authentication layer is we created a permission program on Solana mainnet or DevNet that allows you to create groups and permissions. So you can specify the number of or like different pub keys that can actually read and write, or that are part of that group. Let's say an admin group, or like like whatever specific DAO or whatever you want to call it. And then you can call permissions. You can set permissions, which then are linked to groups, basically. So you can set permissions for specific accounts that are delegated, where you can only those group can read and write. And how the flow will work is, so you have your program, okay? You have your program again. You add the delegation and undelegation features because then you are part of the ER. But in order to add this authentication layer on top of your application that is run there, you need to build groups and permissions, okay? And then once you have done that, what happens is when the user interacts with the UI, on your client, what it does is it basically sends a request to the TE endpoint. The TE will ask to authenticate, so that the user needs to sign a message, say, hey, I'm having this public key and I've signed this message with my private key, and then we can verify and authenticate this user. What the TE will do then, once he authenticates that, it will return an authorization token, a crypto token, basically showing like who and when it was registered. And when the user sends a request with the authentication token, it can then basically see the authentication layer. Oh, okay, this user has permissions to this account, and then I can process. This user doesn't have permission, then I don't process. So that's how the authentication layer works here. So yeah, upon every request, the TE checks and processes that accordingly, like the transaction. Yeah, so that's how it works, high level. And if you want to integrate your program, this is how you can do that. We have like certain, we have again an SDK where you can use that to build instructions to create your groups and permissions. And yeah, this is for the permissions. The other one was for the groups. Sorry for it's not very readable actually. Yeah, I can share the slides with you afterwards. And you can also look in our docs if you have questions. Yeah, so that's how easily you can integrate. So you create groups, permissions, you integrate with the ER, and then you're good to go. Any questions before we go into the next acronym? No, okay. The third one, the VRF, stands for verifiable randomness function. Something that a lot of projects have tried to do, bringing randomness on-chain. It comes with challenges in terms of speed, in terms of verifiability. There were many hacks where you can exploit it, and we found a way how you can do randomness on-chain. Let me show you some applications that we have built for you to see how this looks like. So there's an on-chain dice roller that we have created, and let's say you press on the roll dice, it will create a random number here from 1 to 6 within a second. Or yeah, within a second. You can check it out yourself, roll-dice.magicblock.app. Another app that we created just for fun is, thanks to Andy, also from the DevRel team, is this character generator. So if you have a game, you want to bring loots randomly, right, on chain, or like random characters on chain, you can do that. Also here again, within seconds, where you have specific like stats like defense, attack, and maybe HP, randomly generated for a specific role, or like priest, mage, and so on. So how does it work, the randomness? It works in 3 steps. So how we do that is, we have a VRF program, which is also audited, as well as the delegation program. You can have the full look into the audit report on our docs too. So there are 3 things that you need to do in order to utilize randomness with MagicBlock. The first thing, you have to request randomness. Okay, request randomness. And what it does is your program will send a CPI call to the VRF program with some parameters. One crucial parameter is the callback function that it should trigger, because your program will later receive a callback, which will be then processed to kind of like do something with the randomness. Okay. What it does is, when you do that, when you submit that request, the VRF program will create an item on a queue, an oracle queue. So that queue will basically be observed by everybody, by all the oracles, and only verified oracles in step 2 can actually take that item, computes the randomness proof, and submit it to the VRF program for the callback to be triggered. So the second step, it computes the randomness, it sees the queue, it processes, and creates a randomness proof. Okay. The randomness proof, I will show later, consists of a lot of parameters that is very hard to fake. We will talk about that in the next slide. And then in the third step, once the compute of the randomness proof has been completed, which is like this, like within a few milliseconds, like 10, 20 milliseconds, then the oracle can submit that proof and call the VR program. And the VR program can verify the proof through that inputs and the hash ID that it sees, that it has been verified by that oracle. And then it will create a CPI call to the user program that was indicated in the first place, and it will update the queue that this randomness request has been processed. So then your program can utilize that proof. Okay? Very simple. All happens within 1 second. So looking at the proof, so how's the proof generated? So first, when you submit the VRF to the VRF on chain, it creates a hash ID for that queue item. And this hash ID is hashed through some inputs. So one is the slot number, the slot hash, the Unix times, and the callback inputs. So if somebody really wants to hack that thing, he needs to be able to predict a hash and try to manipulate it. So it might be impossible, but might be also possible. So therefore, we have a second ingredient, which is the oracle. So here, the oracle will sign, again, it will take the queue item, it will sign with its private key, and then create the proof that is being submitted. So a hacker would need to predict the slot hash at that specific Unix time, and at the same time, it needs to have the private key. Yeah. So that's quite impossible, but not totally impossible. But it's quite safe. We have been audited, and you can check it out, the docs, in the report in the docs. Yeah, again, here, just some details how you can integrate it. So in your program that you have, the dice roll, you have like a function, an instruction that creates the CPI code to create a request on randomness. And then you have another one that basically is the callback, which then the VRF program will, the VRF program will call to consume the randomness. So here you can see we have also a few functions for you to actually process the randomness proof, where it gives you an output between 1 and 6, or you can do other things with the randomness too. Yeah, that's so far how we can give you superpower to you and your program. Now I wanted to share with you the opportunities and how we can support you to bring your project to a business. So we have for this year 3 things for you. So one is a Cypherpunk sidetrack where you can earn 12,500 USDC. The second one is the Magic Incubator program, where you get one-to-one support from our engineers, our marketing team, our BD team, and you are also invited to exclusive events, which is the third one. Also, one of them is the Hacker House in Dubai just before Breakpoint. Let me go into detail with that. So you can win up. You can submit your project. You can submit it early. You can submit it towards the end, up until the 30th of October 2025. So it's the same deadline as Cypherpunk. So you can submit on Cypherpunk, but also on us simultaneously. You can earn 12.5K. How we structure the prices is there are 4 prices. The first price is for all, 5K. Second one is also for all, 3K. And the third price is 2K, also for all. But we have a dedicated price if you are part of Super Team. You compete just among Super Team members and can earn 2.5K. So you can earn up to, in this case, one person or one project can earn up to 7.5K. Yeah. And how you can win, you just need to integrate either ephemeral rollups or private ephemeral rollups, what I shared with you, into your project and submit your project, and we will then look into the projects and let you know afterwards. The Magic Incubator, also similar timing, you can also apply here. You get hands-on advisory from our team our engineering team to get your project from MVP to production. You get marketing support, you get strategic guidance on fundraising and so on. You can tap on our network. We have raised 10.5 million through A16Z, so we can help you to tap on these networks too and get fundraising here too. And something more immediate also, what's happening, and something really cool is we wanted to create an environment for dedicated builders building with MagicBlock, where you can learn from peers, from our team, but also from experts that we invite, not only in marketing and technical, but also in pitching and everything else. And we basically created an environment here, this hacker house, which will start from the 28th November till the 7th of December in Dubai, in the middle of Dubai, actually. So it's not outside of Dubai, it's really in the middle, very convenient. Just before Breakpoint, where we rented out this villa, where we bring together 40 builders, workspaces, co-living. So the food and the accommodation is sponsored by us. The only thing that you need to bring is a lot of happiness and ambition and your project and your flight. And we will support you with workshops and networking and pitch demos and so on. Yeah, so this is an opportunity for you where we want to bring your project to really support you to become a successful business. Yeah, you can get started in our docs, and you can check out the demos also and some starter kits if you want to try it out. This is the links to the docs and the QR code. Feel free to check it out. It's just docs.magicblock.gg. And with that, yeah, I'm here also for the whole rest of the day or the week here at Startup Village, Hanoi. Andrea, he is the CEO. He is also here. So you can also talk to him about fundraising or business or about ephemeral roll-ups. And yeah, we're looking forward to support you to bring your project into business. And yeah, that's it from my side. Any questions? Okay, I'm good then. If no questions, we can also take it offline here. All right, thanks.